Today we're going to be working on a hollow spiral candlestick holder. Now this project is fairly large. It's almost 15 inches tall and over 4 inches in diameter. We use the design kit. That allows us to work out all of the cuts in the design on paper before we ever start using the machine. It also helps to identify some potential problems. For example, right here, the router bit will cut evenly on this side and on this side and would ruin this corner. So to get around that, we are going to break this piece into a couple of components. This is the original design. Once I had this worked out, I then drew up this section here that shows all of the components, from the base, the middle section, the hollow spiral, and the cup. You can see this section right here that we're going to build, and it will be joined into the top and the bottom here with this half-inch dowel that's machined on each end of the part. So we'll start off making a blank that's 3 inches square, and we'll turn it round, and then we'll do the hollow spiral section, and then last of all, we'll come back and cut the tenons. This will then be parted right here at this point and removed, so it'll plug into these sections here. Now, if you ordered the plans for this project, then you'll see that this is a three-dimensional representation of this part. The plans will spell out the dimensions for the diameter and the position of each cut. It will also have the instructions or the formula for the hollow spiral, which router bit to use, what pitch you'll use, and the spacing between each cut, and so on. This is just one drawing for this component, and of course you'll get complete drawings for all of the parts. One of the first steps in every project is stock preparation. If you want a turning blank or a piece of stock thicker than about 2 inches, then you're going to probably need to laminate or glue up the stock as shown here. This piece is only about 12 inches long. Technically I could run this through the joiner, but keep in mind that the shorter or smaller the piece, the more danger it is to put it through your joiner. So we're going to use another technique on the ornamental mill and simply machine this surface flat. This technique also works extremely well when you have a highly figured piece of wood, such as a burl or a curly maple, and you want to avoid tear out. Now we're going to use the optional horizontal vices. So we'll slide these clamps forward, and then with the vise open about halfway, we'll just lock that down and close those cams to hold the stock in place as we machine this surface. You'll also need to lower the bed down far enough that you'll clear the carriage. For this process, we'll use bit number 2704. It's a surface planing bit, 1.25 inches in diameter. We'll take this router bit and plunge down until it just rests on the surface of the wood. Next, we're going to move the router bit off the surface of the wood so that we can zero our scale here, and then we're going to drop this down about 15 thousandths, or as much as you want to take off on this pass. Once you're set at the desired depth, be sure and set the stop for the Z-axis. Now, if you're using a plunge router like this on your machine instead of the optional Z-axis, we'll set the plunge depth a little differently. Once you have the router set to the proper depth, you can simply lower the plunge bar. That's like setting 0 on your scale. Then we would use a set of feeler gauges. This one happens to be 15 thousandths of an inch thick. So we would simply position that between the plunge bar and the stop and lock that down. And then when you reset your plunge depth, you would be adding 15 thousandths of an inch to the depth. Now we'll go ahead and machine this surface. We'll want to start on the back side and cut left to right so that we climb on that edge to avoid any tear out. The very last cut will be right to left on the front edge, again to avoid tear out. Each pass, we will move the router over 2 turns or a 1/2 inch. Now we have a perfectly flat surface for the glue up. Now when you clamp up your project, be sure to use plenty of clamps. That'll ensure a tight fit along the full seam. And for this one, we're going to use Type Bond 2. It's an excellent glue for interior wood projects. Again, we laminated two pieces together so that we could get a thick piece of stock. This one is just over 3 inches square. Now you have two options. We can work with this directly and machine it to a round, or you can take the corners off either on a table saw or on a joiner set on a 45. I prefer this method because it makes less sawdust in the machine, less wear and tear on the router bits. Once we have the stock prepped, then we go ahead and mount a hub on one end. Notice that on this piece we put 4 screws in because it's a little larger in diameter and the walnut is just a little bit softer than the maple that we normally use. Also note that you'll want to mark the center and the position of the hubs when the stock is still square before you take the corners off. Now we'll mount the stock between centers, and you'll notice that we've raised the adjustable bed so that it gives us just a little bit of clearance here under the carriage. If you're using a plunge router, you want to bring that up as high as possible. With the optional Z-axis, we can use it a little bit lower if you wish. Set a stop at this end at 1 7/8 of an inch. That way we won't run the router bit into the screws or the hub when we cut the tenon. To mill the stock round, we'll use Magnate's bit number 2704, which is an 1.25 inch diameter surface planing bit. We're going to plunge the router bit down until it just rests on the surface of the wood. Next, we're going to set the stop for the Z-axis, and here we're going to hit the 0 so that we can reference this point for our next cut. Now back the router bit off, and then we'll go ahead and cut a test cut at this end. Now at this point, I'm going to use a set of dial calipers, and I'm going to measure this diameter right here. Now this is reading 3.1 inches. In other words, this is 100,000ths of an inch too large. So we'll reset our router and take off an additional 50 thousandths off the radius. That will give us a 3-inch diameter. We've already zeroed our scale, so we're just going to release the stop and drop this down 50 thousandths of an inch. Now we'll reset the stop. If you don't have the Z-axis, if you're using a plunge router, then you would probably want to use the feeler gauge technique so that you could get exactly 50 thousandths between the plunge bar and the stop. Okay, 3 inches. We're ready to go to the next step. We're going to make 2 identical parts. We have 2 systems for doing that. One is you could complete this one and then start the next one over, but then you have to do all the settings again. So we're going to take this part out and replace it with the next blank and cut it round while the machine is still set up. You can see we have 2 identical pieces. On the second one, we eliminated the test cut, the measuring, and the second setup in order to get it to exactly the size we wanted to.